but just a little bit, because I cannot sleep tonight unless I draw a little bit. Just allow me to draw a little bit, otherwise I cannot sleep. So I'll do that little bit and then go to the PowerPoint right away. It's very interesting, very simple, and I brought a big heart also for you, so it will just make you understand a little bit. And I'm wearing this scarf today because I'll be doing, I did in the morning, the 4 hours, and another 12 hours coming. The lab also, there is a station for the embryology. The reason I'm doing the embryology part, overemphasizing myself, so my part, is that many of the diseases, if you want to be a cardiologist or if you are thinking about understanding the cardiac functions, many of those functions or the structures are related to the embryological part of the heart. In other words, the development of the heart is integral to the disease. Okay? Like many of you know that your relative or neighbor, they say that my child has a little hole in the heart. You will not be talking about any more hole. You will be talking about the real thing, which is called the patent ductus arteriosus, or you will talk about ventricular septal defect, or atrial septal defect, or the foramen ovale, okay, patent foramen ovale. Those kind of words are actually more scientific than having a hole in the heart. So this is the reason, like there are many diseases are integral to the understanding of the development of the heart. So please take it very seriously, and it will help you a lot for a long time to come. So anyway, let's start with the little drawing which I made earlier. So I'll start with that, but I'll not be, as I said, not more than 5-10 minutes. So remember the last time I said that at the bottom you have something called sinus venosus. Do you remember that?
Yes.
Or you completely forgot it?
No.
Okay, I'm very happy to remember that. And then I said that this part is the real heart. And this is the sinus venosus. Remember that? And I also emphasized to you that this is forming the coronary sinus, right? And this is forming the superior vena cava. Remember that? And then I talked about, the umbilical vein and all kind of thing, that these are the vital veins. So I'm not going to talk about this lower part at all. So forget about this. So just emphasize this part. And in my presentation earlier, I did not talk about the right horn. I talked about this one. I purposely omitted this part. So what happens is that right part, which is I'm going to talk to you in a second, but this heart tube is divided into 4 parts. The lowermost part is called atria. Then upper part is the ventricle. Upper part is called above that is called the bulbus cordis. And very upper part over here we call truncus arteriosus, which you will see over there. So not a problem if you cannot see it for the time being. It's called truncus arteriosus. Okay, so I'll draw it properly. So this is the heart tube, and then there will be 2 outflow. This is the diagram that all of you must understand or should do by yourself. In other words, the lower part, all the venous blood is coming. Out of that, one of the venous blood is very important, which is the left umbilical vein, carrying the oxygenated blood. So that blood, if I draw it, that blood over here is going, trickle down and going upward direction and going this way or this way. Since it is coming out, this will be the ventricle. You know that the ventricle has 2 parts. Right ventricle, left ventricle. The right ventricle is attached to the pulmonary artery, ejecting the blood towards the lung. In the embryonic life, that is not working very well. It will be siphoned back. The other one is the aorta, which is coming from the left ventricle. So at any rate, the ventricle is over here. The atria is over here. Atria, ventricle, bulbus cordis, truncus arteriosus, and this is the story of the heart. But the heart doesn't look like this way. So I told you last time, the heart, this is exactly, this is a model. It took me a whole night. So this is the same thing we are talking about. So at the bottom is the atria. Remember atria meaning where the blood is going. Yes. Blood is going to the atria. Coming out is the ventricle. So ventricle is over here and atria is over here. Then it folds, last time I told you. Yes. It folds like this. You got it? Now it looks like a heart. It looks like this way. This is the heart. Okay? So in the heart, which you will see tomorrow if you are the group that you have. So this is the heart. And if I put it this way, you will see the atrium has come posteriorly. These are the two atria posteriorly. In other words, if I hold it and pull this one down, it will be a tube. So in other words, this one, the atria goes posteriorly and up. That's why the base of the heart is formed by the left atrium specifically. And it is a little bit up. It was over here. Atrium was over here. Then it folds over here. That makes sense to you? Yes. Okay. The second concept is, which I did not tell last time, I just orient you a little bit. This part, the right horn, this is also called horn. Horn means coming. This is basically common cardinal vein. Either left or right is also called horn. In the book it's called horn too. So this one coronary sinus, what happens to this part? This part actually goes into the atria. Goes into the atria. In other words, the atria, specifically the right atria, has two parts, smooth part and a rough part. Have you heard the name? Yes. These two things? Yes. Smooth part and the rough part. Now you are thinking about that, you are memorizing it. You don't have to memorize. Do not memorize even one word, then it will not go for a long time to come. It will just go away. By the time you just cross the door, you see it's gone. But this concept will stay there. So remember the fact, atria, in my diagram, this is going over there. So which one is the smooth part? Which is the rough part? Vein is always smooth. There is no muscle. So the part which is smooth is actually the sinus venosus. In the book is also called sinus venorum. It's the same thing. Sinus venosus, sinus venorum is this smooth part which are integrated within the right atrium. And which is the rough part? Rough part is this one, which is I have written already, the atria, which is the real muscle. It's the tube. Heart is a muscle. This is all muscle. But this is a smooth muscle, striated muscle. So this is all muscle. But this is not, vein doesn't have a muscle. So it is a smooth part. So now you go back and open the book and see that is written over there, the right atrium has two parts. Smooth part and the rough part. Then you are thinking, what is the smooth? You are memorizing it, read 10 times, and you say, you are as if you are a big doctor. You pretend like you because you memorized it. Now you are not. If I ask you 10 years from now that right atrium has two parts, then if you answer that why the smooth part is coming from the sinus venosus, then that is the answer. Then you will be okay. Then you are a big doctor. So remember the fact that right horn and the sinus venosus, this form the smooth part and going inside the atria, therefore atria will have two parts, smooth part and the rough part. So if I put a finger over here, I don't know whether you can see my finger over here. This is the inferior vena cava. Okay, I'm going to the inferior vena cava. Can you see my finger? I don't know.
Yes.
Okay, so this part is the smooth part. This part is the smooth. The upper part over here, people say musculopectinating and those kind of names are there, but this is coming from this part, the rough part. Is that okay?
Yes.
Okay, so I'm doing fine. Finally, before I show the PowerPoint. If you look at this one, so it forms like this. So now it's a heart. Is that okay? It's a heart. But if you look at the heart, the front part of the heart is the ventricle. And if you look at carefully, this one is a little bit increased, like it's swelling. There is a little swelling over here. Can you see the swelling? This swelling is named as bulbus. It's a Latin word. Bulbus means swelling. So what happens is, if I put over here, if I keep the same tube, over here, okay, think about it, that one part is swelled up. It's swelling. You don't understand what is the swelling means. If you look at my cheek, it's a good looking cheek. This one. Now if I do, that's called swelling. That's the bulbus. So what happens is, one side swells up. Which part? The bulbus part swells up. So when it swells up, then, very interesting, say one part swells up. We have two parts, one part swells up. This part, it swells up. So when it swells up, bulbus swells up, so this part goes left, because to accommodate.
Yeah.
Not both the parts are swelling up. The part which is swelling up is the right ventricle is swelling up. It forms the sternocostal surface that allows the left part to go towards the left, and that forms the apex. Makes sense why the left side is going to the left. Nobody is pulling in. It is because it's swelling up. Does it make sense to you?
Yes.
And because it's swelling up, the right ventricle is thinner. Is it good or bad? You were just memorizing it. Right ventricle, is thin, and left ventricle is thick. What is this? What is this? Memorizing it. I don't know which one. Then in the exam, you said, it is the right ventricle or left ventricle. Which one is thicker? God knows. Put it number B is correct. Whatever it may be. Whatever it may be, B is correct. That doesn't work with me. I'll repeat, don't worry. Swear. So the reason that right ventricle is thinner, because it swells up. You take a little bit of like a mud or something like that, put it a little bit, make it increase size. It will be, you have to make it thin then. Otherwise it will burst. Is it good or bad?
Good.
So that's the reason the embryology is important. So each and every single structure that you think about it, and it has a mix. So when you are reading it, in the book it's written about that the right atrium has two parts. Smooth part and you say, smooth part is coming. God knows, I have to memorize it. No, you memorize with this diagram, that this is going inside, the right one and this going. The left doesn't go, it stays outside. So therefore it's forming the coronary sinus. But it drains over there. Now you understand, if I say atrium, and I put the inferior vena cava over here, the three things are draining over here. Coronary sinus, superior vena cava, inferior vena cava. The diagram is important or not? Yes, it is important. So it's absolutely no problem. Now I think the time is enough, So we'll go through the PowerPoint now, one by one. So follow my PowerPoint. I forgot to tell you that sometimes you open the chest and you see the heart on the right side. The heart and apex is on this side. That's called dextrocardia. It's written in the book. You can see the dextrocardia means instead of this, the heart is. So which part is increased then? Which part is swells up? The left part, yes. The left part swells up and forming the right ventricle over there. This side is equivalent to, and this apex goes to the. I'll talk about that later because I don't want to spoil my PowerPoint. Is that okay? Okay, let's go through this. Let's go through this. This is the preamble. Preamble means, I'm talking before anything else. This you know it already, and whatever I have written over here, the heart is the first functional organ to develop. Functional, that's what I said. I did not say that this is the first organ to come. First organ to come is a neural tube.
Yes.
But it's not functional. A little embryo doesn't have to do 1 plus 1 equals to 2. Little embryo doesn't go through the CVP. Right? So they should know that there is something coming up, but don't understand anything, that's okay. But a little baby cannot survive if the cardiovascular system is not functional. That's what I say, functional. Then the heart is a unique structure in the body that is derived from the distinct pool of, we call the cardiac crescent, etc., etc. You can see what is written over there. Even I don't read it. I have to cut and paste from something when I show the PowerPoint. Otherwise, students will say, "Oh, Dr. Paul, you did not write it that way." Read it carefully. Okay, there are many things over there, and it's very important. The last part is very important. It comprises of cardiomyocyte, endothelial cells, vascular smooth muscle, fibroblast, and the conduction system. That is important. That you know it already. Now, the important part over here, the understanding of the cardiovascular system, is that the heart is the first organ to be functional, and it beats within 21, 22 days. Then just immediately in the third week I'm talking about. First week is up to 7. Second week is 7 to 14. And towards the end of the third week, the little heart is beating like this. Tuck, 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 like this. So it's functional. And that's probably my next slide will be telling you that heart is functional over there. Yes or no? The heart is developed and starts beating at 22 days. So just after that, 22 days, it starts beating. It's functional. It has to be. Because it cannot cope up anymore from the yolk sac nutrition. So it has to develop certain thing by itself. Now there are many genes. I wrote it over here. This is from your book. Do you have to remember all these things? And I use the same one again and again. If you remember, it's good. If you forget, it's better. So that means you have to know. And if I don't write it, the problem is the students will complain. Dr. Paul in 21st century gave a lecture about that. He did not talk about the genes. Here is your gene. Read as much as you want. Enjoy it. Whole night you spend it over there. I have no problem with that. But we are still understanding. But what is important over there? 500 genes. If you are not satisfied with this one, I can give you more to make it 500. So it's good to know there are multiple of genes, a very complicated structure, and the artificial heart through the stem cell is very difficult to create yet, because we don't understand these 500 genes very well. A day will come, maybe one of you will prepare a heart from these stem cells. That will be the day. That will be Al-Faisal Day. It will be published in Nature, and it will be first news from CNN. What is the first news now? Impeachment of Donald Trump. That will be replaced by yours. Okay. So the bottom line over here is that please make sure that you understand the heart is complicated. The way I put it over here is that to give you an idea that how complicated structure it is. It is complicated because there are almost 500 genes. The 500 genes responsible for the formation of and a couple of genes I just indicated over here. Now, these are important. Where from the heart is coming? If you remember last time I showed you that at the junction where the splanchnic mesoderm, remember the splanchnic mesoderm and the somatic mesoderm? Yes. And on that area, two things are coming and they join together. Yes. So that is the area, it is there. And emphasize these cells now. Neural pressure. If you're writing, because you'll be having 5 questions embryology, definitely based on the neural crest cells. So it is very important that they go into the cardiovascular system and complete the system. I told you already neural crest cells, how important it is. It forms the ganglion. Remember the megacolon? Ganglionic cells are missing over there. So similarly over here, if the ganglionic cells or the neural crest cells are missing, it can create a havoc for the cardiovascular system. Is that okay? So underline that, so then you will understand that what is written over here. So it's coming from the splanchnic mesoderm. Why is it splanchnic? Somebody should say tell that.
Because it's supplied by the autonomic nervous system.
Can you stand up, please? I'll say, thank you very much. What's your name?
Muhammad.
I think this is the best answer, and so quickly. Splanchnic because it is supplied by the autonomic nervous. You should come to my office. Excellent. Like, you feel good. You feel good after, because I try my level best. You will not see that enthusiasm that I have. Even I'm 100 years old, but the enthusiasm is there. And if a student, like, all of a sudden quickly say, because of the autonomic nervous system, man, that's it. That's it. You are number 1 in the world. Remember that. Okay, so heart tube. Now let's orient you a little bit over here. You can see the heart tube over here, this splanchnic mesoderm. Remember, this is the somatic, this is splanchnic. So it's coming from here, then it's forming this together to form 2 endocardial tubes. Then you will be joining together. And you can see the joining together over here. And then it starts folding slowly. So all this, whatever is written over there, every single piece, if you read it, you can understand. I'm not going through that, because I'm not a person of going through the slides, one by. It is there. Read it. And it will be very easy for you to understand it. So the endocardial heart tube and its various parts, you should know: sinus venosa, atrium, ventricle, bulbus cordis, truncus arteriosus. I already told you that. There are many parts of the endocardial tube. The folding of the heart and the formation of the septum, which will come next time. Next time, or towards the end, I talk about a little bit of the septum, because we are talking of the atrium right now. One atrium, then it will be divided into 2 parts, left and right. Similarly, ventricle is there, it will be divided into 2 parts, right and left. I'll tell you a little bit about that in my presentation downstairs tomorrow, or whenever you are coming to me for the lab. Okay, I will just emphasize that. But for the time being, you should know that these are the things should be absolutely clear to you. What is the sinus venosa? Sinus venosa is basically, it is the sinus in space, but the venous system is coming, all the bloods are coming. And then it is going to the atrium, then to the ventricle. Bulbus cordis is the area which swells up to push the left atrium, the left ventricle toward the left, forming the apex. And the truncus arteriosus has 2 parts, the pulmonary artery or the aorta. Folding of the tube and the formation of the septum. Then the aortic arch and other thing, we'll talk about the next time. These are not important for the time being. Now, I wrote many things over here. It's for you to read it. No need of explanation. It's self-explanatory. I go like this way. I love the diagram like this. Straightforward, make you understand. 2 tubes become 1 tube, and then the areas, atrium, ventricle, bulbus cordis, and the truncus arteriosus too. Like my diagram? Yes. Yes or no? Yes. Yes. Clear? Okay. Then the folding. You can see that the back side is what is happening. Is clear now? Yes. Very good. Similarly over here, you can see what is happening. Similarly over here, you can see what's happening. And I forgot to tell you, where is my tube? Over here, paper. Oh, in my pocket. Magic. So, again I tell you the embryology is important, because when it folds, there is a space I told you last time. This space is the transverse sinus. There was a question given to you yesterday that what are the structures present in front of the transverse sinus and what are the structures at the back? You remember the question? Okay. And you did very well. Most of you did very well. But it should be 100%. Because some of the students who did not answer that, they were memorizing it. What is in the front? Oh my God. Is the superior vena cava, coronary sinus, all kind of things you may think about unless you have a concept clear. Because if you know the tube like this, there are the big vessels over here, either pulmonary artery or the aorta, pulmonary artery or the aorta on the front, and it is going back. So the front will be always pulmonary artery or the aorta or the ventricle. Back side will be the atrium and the superior vena cava. And that's the thing. It has a lot of clinical value that Akif must have told you already. Okay? So remember this fact. Okay. So this diagram is clear to you. This diagram is clear to you. You can see how it's swelling up. This is the right ventricle. It's swelling up. It's the bulbus cordis. That part is the bulbus cordis. Again showing in the step by step. I put it together now and put it over here. This is what's happening over in the heart. You can see it one more time. See it, see it. Okay, so only thing I put it over here, this is very important also, that when it is swelling up, the part is swelling and everything is, the heart is there, it is surrounded by also the splanchnic, something which will form the pericardium, which I did not talk about that. The pericardium is coming from the mesocardium, as we call, okay, dorsal mesocardium, which is actually hanging. You can see that heart is over there, and then